Hi dear students, let's see this question that came in KVPY 2018 SX Part 2 Physics paper. This was one of the very easy questions in the whole paper, and I believe that most of the students would have done this quite comfortably. So let's see what's happening over here. As you can see, this is a block of mass small m, and which has been tied from the ground with the help of a string, and there's one more string that connects with a spring of spring constant k, and here we have got one more block which is capital M, and it's given that capital M is greater than small m, and initially the system is in equilibrium. Okay, now string connecting M to the ground, that means this string is cut. Okay, and we have to comment what will happen to the acceleration of the blocks immediately after cutting the string. That means we have to find the acceleration of, let's say, both the blocks. We'll find the acceleration of both the blocks immediately after cutting the string. Okay, so I hope you're clear with the question. Let us draw the situation in the next slide and investigate. So if you see what is happening over here, this is the pulley, this is a block of small m. Okay, and this is the like it has been tied from the ground. This is block capital M, and this is spring of spring constant K. Right now the system is in equilibrium, so can we say that the spring force will be equals to capital Mg? Okay, since the system is in equilibrium, and hence we can say that spring force will be equals to capital Mg. So let's say right now the extension in this spring is x naught. Let us say the extension in this spring is x naught, so kx naught will be equals to capital M, correct? And this kx naught will also be equals to tension in this string, right? Which is obvious, because this tension will be this tension is nothing but the force with which this string is pulling this spring. ये टेंशन वो फोर्स है जिससे ये स्ट्रिंग इस स्प्रिंग को पुल कर रही है, and which is nothing but mg. Okay, so we can say that this will also be equals to tension, this t. Now if we find the initial tension, although this is not required, but let's just do this. इसमें स्ट्रिंग में इनिशियल टेंशन क्या होगी ये निकालने की जरूरत नहीं है क्वेश्चन को सॉल्व करने के लिए, बट जस्ट ऐसे निकाल लेते हैं, ठीक है? सो वी कैन से दैट ये जो ऊपर वाला टेंशन है इसकी वैल्यू वी ऑलरेडी नो. यहाँ पे एक फोर्स mg ऐसे जा रहेगा, एंड दिस लेट्स से इज t1. So we can say that T1 plus mg will be is equals to capital T, and hence T1 will be is equals to m minus m into g. So this is the initial situation. Now we are cutting this string. ये string काट रहे हैं, ठीक है? Now ये string कटते ही यहाँ की टेंशन जीरो हो जाएगी. Of course यहाँ पे कुछ है नहीं तो यहाँ की टेंशन जीरो हो जाएगी. But think carefully, क्या इसका x immediately चेंज होगा? इसको कट करने के बाद क्या इस स्प्रिंग का x immediately चेंज हो जाएगा? So the answer is no. It will start changing. It will change after a while, but immediately after cutting, we can say that this x will remain as it is, and hence the spring force will also remain as it is. So my dear friends, if you see, spring force remains constant immediately after cutting. Spring force remains same immediately after cutting. Remains same immediately after cutting. Okay. So this is what we are going to use in this situation. तो अब इससे क्या होगा? इफ यू सी स्प्रिंग फोर्स की वैल्यू कैपिटल mg के इक्वल थी, एंड हेंस वी कैन से दैट इस पे अभी भी नेट फोर्स जीरो ही है, बिकॉज kx नॉट इज स्टिल बैलेंसिंग दिस कैपिटल mg. सो वी कैन से दैट मतलब इस पे kx नॉट ऊपर जा रहा था, mg नीचे जा रहा था, सो kx नॉट की वैल्यू mg के इक्वल थी. सो वी कैन से दैट एक्सेलरेशन ऑफ कैपिटल m विल बी जीरो because net force is zero. However, on the small m, this tension will is still equals to mg, because यहाँ पे ये जो स्प्रिंग है अभी भी इस स्ट्रिंग को कैपिटल mg फोर्स से खींच रही है. तो if you see this small m, तो स्मॉल m का एक्सेलरेशन कैसे लिखा जाएगा? एक्सेलरेशन ऑफ स्मॉल m, इसके ऊपर की तरफ फोर्स कैपिटल mg का है एंड नीचे की तरफ स्मॉल mg का है. दिस टेंशन हैज gone out of the picture. So we can say that capital mg minus a small mg divided by small m. So this will be the acceleration of this small m in the upward direction. Okay, so I hope you're clear with this. Let's go back to options. So the magnitude of acceleration of small m is 0 and capital M is g. This is wrong. The magnitude of acceleration of small m is m minus m g by m, and that of m is 0. This is exactly what we have found. Acceleration of capital M 0 है, and small m का m minus m into g by small m. This is what we have found. Acceleration of both masses same, of course wrong. Elongation in this spring is m minus m g by k. This is wrong because elongation in this spring was mg by k. Okay, so this is wrong. So option D is also wrong. and hence we can say that B is the correct answer. A fairly easy question. Most of the students would have done this without much problem. That's it. Thank you.